Hi everybody, Chris at Torque King here, and we thought we'd give you a little idea of what we do for research and development. We're doing a podcast in the near future, and when we do, the pod that we're going to cast out of, which is actually a little on the nose, is an old communications shelter from Army surplus. The handle that was on that pod was broken. Both the inside handle and the outside handles were broken, and to find another one has proved to be very difficult, so I decided to go ahead and model one up and print one out, and eventually we're going to have one that's printed and painted that looks like it'll match everything on it. But we thought we'd go through the basic process of a research and development on a small part. I got all the information I could from what's existing. I got the broken door handle part, and I've got dimensions off of that, and I have them in my sketch here. It's just a quick rough sketch. This sketch doesn't need to be perfect. It just needs to get me the idea of where things are at and dimensions. And I used just a Harbor Freight caliper to locate all the dimensions, how far I am from the end of the piece, how deep the hole is, how wide the whole piece is, how wide it is where the relief is. So I take a lot of measurements. Not all of them are written down here, but after I got my basic shape into SolidWorks, I finished off with getting the rest of the final dimensions. The one I forgot was that depth. So when I printed this first initial part, I only had it cut through that first round portion, which is the first part of my sketch in SolidWorks. So my idea with this was to kind of follow this line here, which is just a parting line. I don't know what they'd call it originally, but that line there is my original idea to follow. And the way that I drew it up, it didn't come out quite that way, but I'm not disappointed with the facet that I have here, or the fairly flat handle face. The only thing I want to do different when I change this a little bit is lengthen the handle. So the thing about the way I do my research and development, and that's really sounding a lot fancier than what it is, but when I envision a part and I want to produce that part, it's not really a step 1, a step 2, a step 3, a step 4. And I can try and break it into that, but what it is really to me is the initial process. Think it through, and in that process sometimes I do physical sketches with pen and paper, pencil and paper, stuff that I can change. Talk to people about what it is. I do research on what the existing options are, and I try and take the best features of everything that's currently available and combine it into what I want to do. So a handle, very simple. Basically we want to be able to grab the handle, turn it, and open the door, but it has to fit all the physical parameters of working on the door, and things that you don't necessarily think of when you're first developing a product is what happens once I turn this handle 90 degrees. What's it going to hit? What's it going to be in the way of? And that's why on this particular part, this little slot, that little indentation right there, I included it, and I didn't know why it was on there when I first looked at it. I hadn't thought about it, but when I put it up against the door, there's a piece of the door mechanism that needs that relief there that won't work properly. If you don't have that relief, you won't be able to unlock the door all the way, unbolt the door. So the process is more of a 1, 2, back to 1, 2, 3, back to 1, back to 2, back to 1, back to 3. It's all over the place, but that's kind of how it works out. You try and streamline it as much as possible, but when you're trying to come out with a product, whether it's a door handle or a new wheel hub or a bearing or whatever the product may be, the more complex it is, the more back and forth you're going to have. And you have to make sure that your final parameters are going to work with everything else that you wanted to begin with and everything else you've found along the way. So we're using SolidWorks 3D, which is industry standard just about. It's one of the best programs you can get. It's a buy once, cry once kind of thing. It's not cheap, but it's well worth the money you pay for it. So on this particular door handle, I started off with this very basic sketch. Just the initial shape of the first portion that I'm making, and the shape of the hole in it, and the shape of that relief I talked about just a moment ago. So the next step, once I've gotten to this point, I've gotten my drawing, is I'm going to export it as an STL file, and I'm going to go into Prusa, and I'm going to import it, and from there I'll turn it into the file that's needed to run the 3D printer. There's our door handle file, and it loads in. So I'm going to rotate the part into position, and we printed one already and decided maybe it would print easier this direction, so that the support lays under the handle in this direction instead. Okay, so we've got this first version I've printed, and what I'm showing again here today is still the same first version. I haven't made any actual changes to it, but just to give you an idea of how this works, I'm going to slice this drawing, and now I have a file that shows support where it needs to hold the part up, because when it's printing it has to hold that up. It can't just print it all out into midair. So we're going to print it in this direction and only support the outside of the handle. We're going to add a little thickness to it when we do the next print, and we'll have some more room to sand it smooth. But this is what that file is going to look like, whether I leave it in this original configuration or change the length or change whatever. You're going to have a file that looks like this, and you can look around the file and see how everything looks. Make sure that it's going to fit on our table, and it does. Now we're ready to print it. So the next thing we do is export our G-code. We'll save that off to the same place as the original file. And there we have it on our desktop over here. It's just that simple. It's a G-code file. So I put that file onto card, and I'll put that SD card into the printer, and then we'll print the part. That's research and development in a nutshell. It's a lot of back and forth, a lot of checking measurements, a lot of checking real world parameters. Is it going to fit in what I'm doing? Is it going to work with the chemicals that it's going to be around? Is it going to work with the physical environment? Is it going to work however many different ways? And with this simple door handle, it just basically has to be able to handle being turned multiple times, open the door strong enough to do that, fit snugly so it doesn't loose and works itself to a break point at a too early a stage, things like that. So that's what we're doing a little bit more of here all the time. The next step along our way in our research and development is this adapter that I'm working on here. We have an existing solution for that particular problem, but parts are going to go away, and so when the parts are gone, we hope to replace that with our own solution, and that's the reason we're working on it here. So
there's just a basic overview of our research and development and how we look at it here at Torque King. Thanks for watching. I hope you enjoyed what you saw. Give us a comment if you thought there was something interesting or something different we could do, or maybe you've got a solution that you can see over my shoulder you'd like to share with us. Go ahead and leave that in the comments below. We're glad to hear it, glad to look at it. And if you like what you're seeing here and you like what you see in the rest of our videos, give us a like, subscribe, come back and see what else we're doing next. Thanks for watching. Have a great day.